move on to the first keynote speakers, and it will be Anders Källström and Christian Grante who share this time together. They normally share their days at Volvo Group, and all of those of you who have a Volvo family car and think this speak will be about the history and the future of such cars will get a different picture here. With that, I welcome our two plenary speakers.
Thank you very much. Thank you. We will just switch over computers here so we get the films running. My name is Anders Källström. I am the spokesperson for automation and connectivity in the Volvo Group. And today I will share with you, together with my colleague Christian Grante, who is the technology specialist on automation and connectivity. We will share with you Volvo's views on automation and connectivity. And as was said here before, Volvo Group is sometimes confused with other leading company, Volvo Cars. So I think my first slides, when we get it, is about the Volvo Group.
I need your support.
You need my support?
Yeah.
I'm sorry. There we go. So the Volvo Group is a leading company in the world for commercial vehicles, making medium and heavy-duty trucks, buses and construction equipment, engaging around 100,000 employees, having manufacturing in 19 countries in the world and selling in 190 markets all over the world. So that is a very brief, here it is, brief introduction of the Volvo Group. And of course, our industry is transforming with the new and recent advancements in automation and connectivity. So let's have a look at that quickly. I think there was one before, wasn't it? Here we go. So it's all around us already. Things are being automated. On this slide we have lawn mowers. Many of you have them already at home. We have fully automated warehouses. We have drones flying automated with boxes. We have, in fact, control towers controlling several airports at a time from a remote position. We have drones, and all of you, of course, know about the Google cars and the fully automated Volvo cars, which will run in Gothenburg in the next year. So this is a transition in our industry that is going on right now as we speak. And Volvo is very, very active in this area as well. So, but it's getting close. I think I have another example here which is quite interesting. So this is a small bus, or is it perhaps a passenger car? Nevertheless, it's a fully automated transportation system that runs in a university campus. It's also fully electrical, highly representing a kind of future transportation mode. What's interesting with this picture is that, of course, it's already there, but also that it kind of is blurring the distinction between what is a passenger car, what is a bus, what is public transportation. Old truths are being questioned and challenged, and this also addresses the business models. So we are going into a very exciting future, that's for sure. We have another example. And this is a fully automated mining truck of enormous size. And this is also already in commercial operation in a mine called Rio Tinto. So this is driving all by itself. It's monitored by an operator from a remote place as well. So you can see that our traditional markets, our traditional way of making products is highly challenged. And we must address this and respond to it. And we respond to it not only because of that competition and that the technology is moving closer to us. We also address this because of the benefits that we see in many areas with working with automation and connectivity. Is it flipped? So here's the handful of reasons for why connectivity and automation is good for us and for the society and for our customers. It's not all these terms on this slide are quite wide. You can understand them in many different ways, so I will elaborate a little bit on each and every one here. Starting with cost as one of the benefits about automation. One of the most obvious is the cost for our customer. If we can reduce the fuel consumption, we reduce our customers' cost. So that is, of course, a very strong driver. But there's also other types of costs. We can think of environmental cost. You can think of cost for infrastructure, road infrastructure. With automation, we can make traffic more dense and more efficient, which means that we perhaps need not invest so much in bridges, in tunnels. We can utilize what we have in a better way. So cost is one big driver which we can address efficiently with automation and connectivity. We also have safety, a very strong driver, one of the core values of the Volvo Group. And with these newest technologies, we can make trucks, buses and construction equipment much more safe. We can compensate for things that drivers cannot handle, and our automated systems can address that much quicker. We ran a platooning demonstration throughout Europe quite recently this spring, where we had, I think Christian will tell you a little bit more about that, but those were trucks that were connected through Wi-Fi, and for example braking signals from the first truck in such a convoy were transferred with no delay to the last truck, so that they were all braking like one big train. That's a kind of safety which is near term to be introduced. We have environment benefits as well. One of them is kind of obvious. If you reduce fuel consumption, you reduce the carbon dioxide, so it improves the environment. But it also improves kind of city environment. If we can make traffic flows more efficient, we can make the city environment more attractive. The third environment is the driver's environment, because automation also addresses the way drivers drive trucks and buses and construction equipment. So we can make that more convenient. And that actually addresses one of our industry's main challenges, which is to attract new drivers. In many parts of the world, we have difficulties in getting drivers to the trucks and getting then the transportation system going. So by making driving a truck more attractive, more easy, more convenient, more relaxing, we can actually make the environment for the driver better as well. I would say that these three first are the three main drivers. Then we can also utilize the technology for improving maneuvering in very tight spaces, which can be very tricky. I don't know how many of you who have tried to reverse with a long vehicle combination. It's for me almost impossible. Skilled drivers are excellent at it, but a newcomer needs some assistance, so we can do that much easier with automation technologies. And then last but not least, these were kind of direct effects of automation, but there are secondary effects as well. For example, when we improve the transportation system in a mine with an automated truck, it doesn't only mean that the operator of the mine will make more money and improve his productivity, it also means that the society around the mine can be sustainable, and the prosperity of the community dependent on the mine can actually be improved. So those are secondary societal effects, which also comes from automation as a second step, which is quite interesting. So my last slide, maybe I give the impression that it's a walk in the park. Let's go do it. It's very exciting. It's very fun to work with. However, there are still challenges, of course, and if we go to the extremes with full automation, there are a number of challenges, of course. I already mentioned that the business models are challenged. For example, when it's not so clear if it's a passenger car, if it's a bus or so, it will change the way these products are bought. We need standards and regulations, because an automated vehicle is very much an integrated part of some kind of ecosystem. So it's no longer a standalone product that you can sell and let the user just use it. It's an integrated part of something more. So that's why we need standards and we need regulations so that this can happen. All of that is not in place yet. Cybersecurity, such trucks and buses are of course communicating with infrastructure, they are communicating with cloud solutions. So there's a need for cybersecurity to secure all these connections and all the data that is shared as well. We have infrastructure, I will not elaborate so much on that. Liability, when a vehicle is making the decisions, who is really responsible for the operation of the truck. Social acceptance, and we have resource and competence as well. This brings us into new technologies, it brings us into new areas where we need to build resources and competence as well, which is a challenge, but it's underway. So that was a quick high-level overview about automation in the Volvo Group perspective, and we leave then the word to Christian Grante to go more into some hard facts about automation. Thank you very much.
Thank you, Anders. You're the expert in this area, so I will dive into the challenges that we see in front of you, the challenges that we basically want your help with. As Anders said, Volvo are manufacturing commercial vehicles, so productivity is essential. That's really what our customers buy. Some of my colleagues say that that's the only thing they buy, and then I try to get them to explain the custom paint that trucks often have. It's not easy, but it's more than productivity. We know that energy efficiency is part of productivity. The numbers you see here is benefits that we see with automation. We know that the productivity can go far beyond if you look at not only the vehicle but a system of vehicles, for instance like the mining that Anders spoke about. And we know that energy efficiency then also, if you look at the systems of vehicles, can go far beyond this. But where Volvo is coming from is basically safety into this area. So if you play, what we see is currently that about 90%, we tend to say, of the accidents that we have, the core is the human. Last survey I saw, it was 94, but it's there somewhere. Then, knowing that, we should also recognize that the drivers do prevent a lot of accidents. So the drivers are skilled and they do know how to handle complex situations. If you go to the next slide. Safety and also reducing injury, basically. It goes back to the foundation of Volvo and the core values of the founders of Volvo. And we have made a lot of innovations from Volvo in the area of passive safety. A lot of steel, but also seat belt and so on. In the 90s, we started to get the active safety systems, as you know. And if you click, and I think you need to press it as well, we started to get the active safety systems. And you might have seen this one, it's on YouTube. It's Magnus running the truck and Peter is riding in the car. He's one of the developers of the system, and as you see, he do trust the system. So with active safety, we definitely have improved. This is, if you just go back a slide, again, back to that. We have improved safety. The rear end collisions with commercial vehicles was one of the biggest contributor to basically severe accidents, especially in Central Europe. Now, what we have looked into, of course, going further in the active safety is basically the lateral safety. Because now, since we are handling a lot of, especially the high-speed rear-end collisions with this system, we have still left the ones that are basically going off-road and into oncoming traffic. It was not as easy as we thought when we set out. A truck crosses the lane markings in average 40 times an hour on purpose. It makes it hard to have a system that intervenes depending on, for instance, the lane marking. And that's what we currently at least see. Which means also that we see a drive into automation, because a way of not getting a driver upset with interfering when you cross the lane markings more than once every 2 minutes. It's actually to automate it so that the truck do the lateral handling for you. So if you continue, next one. When we look at automation, it's a lot of people that I speak with, they tend to say that, well, we take out an ordinary truck and then we put in an automated and then we're happy. And of course that would be nice, but it's not that easy. So what we try is basically to break it up into scenarios that are fairly easy to automate. Fairly easy. It's a challenge. Fairly easy to automate. But the end that bring a lot of value to our customers. So if you click again, the first example that also Anders spoke about, and also because you were the project manager for that one, it's platooning. It does provide us with a new safety feature. Since we have communication, we don't need to wait until the inertia of the vehicle have gone so far so that the vehicle starts slowing, and then all the measurements that we need on the radar, but we can go straight. What is neat with the system is that it also saves fuel. Basically, if we can harmonize the drive lines, we save fuel. But we also then, of course, save fuel if we can go closer into using the aerodynamics. And you click to the next slide, I think. The challenge here is basically, it comes down to safety. Today, we sort of tend to divide safety into functional safety, the product safety, and into traffic safety. What is, when we automate, we can't blame the driver for the traffic safety anymore. So basically, the situations, the environment becomes limiting in a functional safety perspective. Nothing new, but it's a big challenge when we go. If you click once more, when we go into, as you saw, platooning, it would be nice to go down here. And we have had Sartre project that demonstrated this on roads, but the problem is the many situations that you need to tackle, which means that we start with a bigger safety distance, because it's basically the distance between the truck that provides us with the safety and the platooning. We want to shorten it due to the aerodynamic effects. If you're really close, you can gain up to 20, and you're in the middle here, you can gain like 25% in the fuel consumption. And it's a driver, it's definitely a driver. Which means that we want to shorten the distances, but still remaining safe. And safe is basically a function of then the consequences if we do something wrong and how often it happens. So we try to go down. And we basically have a system that is a couple of layers. So today, with ACC, adaptive cruise control, we do have all the safety in the measurements from the radars, camera. When we go to CACC, as Anders said, we also rely on communication for safety. And we do have a backend providing us with, for instance, that the weather conditions are right, traffic conditions and so on. But when we go down into really close distances, actually the driver can't see to drive steer laterally, which means that we actually have the driver out of the loop. A very big challenge. So if we go to the next one, what we have seen when we are driving in platoons, it works fairly well when it's flat surfaces, but we can get really poor performance when it starts to get hilly. it depends on that, especially commercial vehicles are different. They climb the hills differently, depending on the weight, the power, and so forth. So if you when we run the classic control and just have a gap, it works well on flat. What we need, and that is a challenge, we need to go into predictive controls, for instance, which use the topography to optimize the fuel savings. And what the gains that we can go, especially make when we go from a control of just a fixed distance to a dynamic distance are huge. They're huge, and this is really what you need to deal with the potential. The question is if each truck is on their own or if they should cooperate, because you have even bigger gains if you then central control the trucks. But that also means that, for instance, the first truck can start losing fuel gains, depending on that the other ones should say more, so that they all say more. If you click on that one, now our competitors have really neat films production. This is from a cell phone, but it shows the concept of the high-route pilot, and it's obvious that for commercial vehicles it's important to get this kind of feature. It has to do with lateral safety, but it also has to do with productivity. What we see is that the drive times, we have in commercial vehicles you have drive time, work time, rest time. And if you can calculate basically your driving as work time, you have twice as much driving time. It increased productivity. And it's been challenged at the moment. And which means that it's definitely something that would make our customers more competitive. Now, of course, there are challenges. The lateral position, basically the localization of yourself is key when it comes to automation. And it needs to be extremely robust. It's dangerous to drive off the road, which means that it can't happen. So although that we have really nice ways of keeping on the road, it has to be extremely robust to be in production. And this is a challenge for us. Also, since it's more dangerous, for instance, than the auto brake system, it comes with high requirements, extreme requirements. To do the lateral control, the full control, it's like 100 or 1 million times higher requirements on that one, which means that the verification and validations is a problem for us. That is what we need to crack, how to make a robust system and to prove that it's robust. Otherwise, we can't put it on the road. You have a handover problem between the truck and driver. We have a lot of people investigating it. Still, at Volvo, we believe that we can't rely on it, but basically have to have a risk maneuver that we can perform without getting the driver back into the loop. We are fortunate with the commercial vehicles that we actually operate also in confined areas. And here you can go faster into automation. We can go into high-level automation fairly fast. Mature technology before we put it on the road. If you click, probably need to start the left one. So what you see here is this is actually this is our mining truck, and it's running underground in our underground test track. Actually, it's hissing at the island that you are in currently. So it basically shows you that the technology that we need for the road is available and we can handle it. So it can position itself depending on only the environment sensors and drive. What we choose in the mine is that it actually has a roof, so no one that isn't supposed to be there is in this environment. And then we need to evolve safety issues. This one, the wheel loader, we are really proud of. That's a tricky operation to do without the driver in the seat. To dig into pile that changes, and it's actually just using LiDARs also to define the hole. If we go to the next system, we do still have a number of challenges in this, and again, localization is one. For us, being a vehicle manufacturer, we are used to manufacture one vehicle. And now we are basically connecting the vehicles into a production system, which means that we optimize across the system. That's a challenge for us at least. We need to get these vehicles to be really productive to run in mixed traffic with other vehicles. Yes, as on the roads. Easier here, still a challenge. And we need to make it cost efficient, we need to distribute safety, not put all the safety on the truck, but actually also have it in the infrastructure. Sort of the same challenges as we see going into, for instance, urban areas and active safety in urban areas, which is difficult with only sensors on the truck. So, just to conclude, and basically going back to what Anders said, automation is important for us as a commercial vehicle manufacturer. We see that technology is available. We can get the autonomous truck going in the mine, but it's really safety that sets the boundary. We need more robust systems. And verification and validation is the real challenge to prove that the systems are safe before we put them on the road. What is as you saw, infrastructure adaptation is probably needed. It's easy, fairly easy to automate 70 or 80%, but the last percentage of these scenarios that you didn't think about, that you didn't see were coming, or crossings or so on, those are extremely tricky and extremely costly on the vehicle side. In the mine, we changed the infrastructure. So if we have a challenging crossing, you rebuild it so that you don't have the crossing. And it's probably something that we will see happening also on public roads to pave the way. Thank you.
We have a full program, but it would be a shame to let you go without one or two questions. So are there any questions here? There's also the possibility to catch them at the stand. In that case, I have a question. I mean, I'm a university researcher, and with me many here. What do you think, what should we do at the universities, and what should we not do? What do you do better inside Volvo? And what do we do better at universities?
Wow. My immediate response to that is that...
You don't want to answer?
No, I do want to answer, because maybe I don't give you the answer that you expected. Not only with universities, but with policymakers, with other stakeholders. It's a collaborative effort. So I think cooperation in this area is really key to make it happen. So I would rather put it the other way and say that we need to work together and not perhaps split it up and create new borders of you do that and we do this and we do it better than you do. It's a kind of, I shouldn't say it's the wrong question, it was a good question, but nevertheless I think in all cases where we talk about automation, we really want to focus that we have to do it together. So that is perhaps the message then.
And then we also really like to see a lot of applied research, because we believe that's what pushes us forward.
Okay. Any other questions? Otherwise, yeah, we have one from Christoph Stiller.
So, thanks for the nice presentation.
He's also on my side.
Yes, universities. My question is, what kind of infrastructure modifications do you expect in the long term happening through automated driving? And who will pay for it?
I can take that. Basically, as you saw, we are focusing on highways, and that depends on that you have a fairly nice setting without crossings, traffic lights, and so on. If we want to go into the more complex environments, we do expect that the infrastructure should support the trucks going into those. So for instance, and you can see a lot of research projects, some are actually starting to deploy, that you're equipping, for instance, crossings with sensors. It's much easier to equip the crossing with a tailor-made set of sensors and communicate the perception to the truck than to equip the truck with sensors that should then cope with any crossing. So we would expect that those kind of changes will happen. Also that you can get certain areas for commercial vehicles, for instance, the bus lanes are really nice in the cities if you want to start changing infrastructure, so it's easier, I should say, to go in with automated vehicles in the city. So that's the way we believe it's going to go.
Can I add the connectivity piece, perhaps?
Yes, it's extremely important.
Just to add to it, we're also dependent on very reliable, robust and high-speed quality of connectivity. So that is also key, because these trucks will communicate with each other. They will communicate with cloud and back office solutions, and that communication has to be perfectly safe and reliable. So that's another piece of the infrastructure which is important to develop.
Okay, with that, I think we have to move on to the next session. Thank you very much again.
Thank you. Thank you.